I'm Paul Brodie. We're in my shop, myself, fabricator, Mitch, filming. We're going to do an episode on the Excelsior. This will be the first episode we've done on an Excelsior. This is a 1919 overhead cam Excelsior board track racer. And I think back in the time there was maybe 3 or 4 of these bikes made, and then as the years went by they got lost to history. Either they were sold as scrap, or I don't know what happened to them. Nobody really knows. So in 2005, I'll just tell you a little bit about what was going on. I had a company called Aramaki Northwest, and I was working on Aramakis. I was also working on a lot of other bikes as well. I was working for other people mostly, and there wasn't a lot of flow. So I decided that I wanted a big project to work on. And right around that time, my Aramaki race bike got stolen. And that left a big hole in my shop, a big hole in my life, because I've been the Aramaki guy for quite a while. So I decided that I was going to focus on Excelsior. So that's what I did. I had a black and white photograph, so I started working to make this motorcycle. Basically, you could call it, I call it financial recklessness. I turned away all my regular customers. I started living off my line of credit, and I started buying parts to build these Excelsiors. So that's kind of the story of how I got to be working on these bikes. It became known as the Excelsior project. And I wanted to build these bikes, and I also wanted to build a race bike because I lost my Aramaki race bike. So over here is the Excelsior that I built. I called her Ruby Racer. And you can see there's an Excelsior motor here, although it's got a different transmission, it's got suspension, it's got brakes, so it's a lot different from the board tracker that had no transmission, no brakes, no clutch. So we did that, and I thought what we'd do today is to look at this Excelsior motor. This is number 6. I've built a few of these. And this is number 6. So we're going to take this engine apart and you can have a look at the inside. I thought that would be a good thing for us to do today. How do you make a motorcycle from scratch? Well, you make up a drawing and then you figure out the size and the shape. You have patterns made and then you have the casting. So this is a raw casting of a cylinder head. And it doesn't really have any machining done on it whatsoever. Over here is a barrel. It's aluminum. There's no machining done on that. I do all that stuff. On the crankcases, I got them cast and then I had them CNC machined. But these parts all get manually machined in my shop here. So and then it gets all sanded up and polished. And so let's go over and have a look at the motor. This piece here is not standard. There's a drive for the magneto that comes out here. This is electronic ignition. There we go. That's where the electronic ignition sits. On the carburetor, it's a Schebler carburetor. It's 1 5/8. This is known as a ported air sleeve. You can change the mixture even on the fly if you want. This is the choke. There's 2 positions. That's full choke. That's half choke. That's run. We'll get into the carburetor later because it's an interesting design. It's not like a modern carburetor at all. Back in those days, pretty crude compared to modern carburetors. I built this motor in the fall of 2018. I was working on a project with a young builder, a talented builder from the island, and we had a plan to put this into a custom show. He was going to build a frame, and the stars just didn't line up. I broke my leg and ended up in hospital. Someone else that was involved to ride Harry High Pipes the next year, he died. There was a lot of stuff going on, so this engine has sat for a while, and I just got it back. It's basically new. So we're going to have a look inside. Here we go. I had custom wrenches made. I think they were laser cut, and then I sanded them and had them nickel plated. Nice. This is the bevel drive in here. You're going to see that. So these have to be loosened off. I designed this motor, the inside of the motor anyway. I sat in my shop over there for 4 months back in 2005-06, and I had a 486 computer, AutoCAD 12. Pretty cutting edge, I know. And that's how I designed this motor. So you can see in here now, that there is the bevel drive. It drives off of the crank. See, there's a gear there, so it's 1 to 2. All these shafts are spinning at half speed. So that's for the magneto or the ignition, front cylinder, rear cylinder. I want you to see this. See, there's a groove here and here. What the groove is for is so that this wrench lines up. It took me a while to figure out this system here. I did not have a system when I first started making these engines, and so I had a lot of trouble in torquing down the cylinder heads because I couldn't get a wrench in there. So this really solved the problem. If you know about old motors, the Excelsior was inspired by the Cyclone motor, and that was another board tracker that was pretty well respected back in that time. There you go. It just pops up. That's not supposed to happen. That should get Loctited. But you see, this is all, it's all modular. Can you see the camshaft there with the lobes? So the next step is to get the heads off. And to get the heads off, you have to take them up at the same time because the intake manifold, it goes into both sides. You can't just pull one head off because the manifold will stop it. So we're going to use the same wrench again. That's the inside of an Excelsior head that's never been used. When I was racing Ruby, I had a lot of problems with the head gaskets. Can you see how they're all deformed? And they would blow out. I'd hear a hiss as I was going around the track, and I knew right away when I heard that little bit of a head gaskets was going. So to solve the problem, what I did, it's called O-ringing. You O-ring the cylinder. Can you see here how there's a groove? If you look over here on the cylinder, can you see that right there? That there is a piece of safety wire, and I think it's 032 or something like that in thickness. So you take a little parting tool and you set it up in the mill, and you make a slot or a groove that's 2 thou smaller than the safety wire, and then you hammer in the safety wire. So the safety wire is, can you see how it's raised up? It presses into the head, into the copper head gasket. The head gasket can't blow out anymore. So that's called O-ringing the cylinder, and it works. I had problems with the studs pulling out, so I made custom inserts out of stainless steel. What goes into the cylinder here is a 1/2" National Fine thread, and then it's counterbore, and then there's 3/8 National Coarse. Because not only was I blowing head gaskets on the racetrack, I was pulling studs out of the cylinder. So I went through a whole evolution of learning how to build a motor that would work on the racetrack and not just on a test stand. It's very different. When I was racing Ruby, a lot of the times I went to the track and there'd be some sort of a problem with the motor, lots of problems with the lubrication system, and then I'd come back and I'd tear it down, the whole motor, and I did that probably something like 11 consecutive times. Go to the track, do some laps, come back, rip it all apart, make some modifications, go back to the track. That was my life for a little while. And I'm not just going to pull it off. I want to leave the piston inside the barrel. There's the circlip. So it's a JE piston, a Carrillo rod, for those of you that have heard names like that before. So there we go. It's modular. All the shimming all stays in place. So can you see this tube here? How it goes into the pinion shaft. Can you see how actually this is loose in there? What I did was I flared the end a little bit to get a little bit more oil pressure. So this is a modification. This wasn't on the first ones I built. So that's the oil pump. So that's return and that's oil feed. There's actually 2 oil pumps inside there. This was added later. This is the oil return line. I had a lot of problems with the scavenging, making the oil come out of the crankcase. And for a lot of the races I did in the early part, the crankcase would fill up with oil because the scavenging wasn't working properly. And then I'd puke oil all over the bike. Once the track, that was not good. They told me if I ever did that again, the bike would be banned from Seattle racetrack. That was not good. So anyway, this is one of the solutions, external oil line. It kind of alters the look, but these bikes had a lot of plumbing on them, so not the end of the world. There we go. That gets torqued to something like 75 pounds. It's pretty easy. So there's a key here, 3/16 key. I had these shafts custom made because I couldn't find anything. It's kind of like Harley Davidson parts, except not really. I couldn't buy screws like this, so these were all CNC machined. There we go, it's free. There we go. You can see the Loctite gasket sealer I use, it's orange. A magnetic drain plug. See, when the engine's working, it goes around this way. This is what takes the oil off the edge of the flywheel. This is like a scraper, an oil scraper. Then do you see here, I machined this little piece here, and it collects oil, but it goes right down there. See, can you see the hole in the bottom? It sends oil to the outside of the bearing, because otherwise oil wouldn't get to the outside of the bearing. I discovered that pretty early on. It's a Truett and Osborne flywheel setup. Can you see there? It's Truett and Osborne. They make a lot of race parts for Harley, Sportsters, whatever. So I had the flywheels custom machined. It's a custom stroke, and the rods are custom as well. These are very long rods to make the engine look like the stock. So there you go. That's your 1919 Excelsior teardown. I hope you've enjoyed watching. Mitch and I like coffee. If you buy us coffees, it fuels the channel very well. Thank you. See you next time. We'll do something else. Take care.